Diag4Bike Diagnostics currently focuses primarily on Harley-Davidson motorcycles, including Buell. Serial diagnostics of Harley-Davidson motorcycles is supported by all control units with J1850 and CAN protocols. In other words, motorcycles with 4 or 6 ping diagnostic connectors. Diag4Bike almost exclusively displays information provided by the motorcycle's control unit. This information is then relayed to the connector of the control unit. That means, for example, that if the diagnostics discover a record of a fault of the engine's temperature sensor, the sensor does not necessarily have to be faulty. The fault may also be in the cabling leading from the sensor to the control unit's connector, or in the connector itself. Diag4Bike's menu is very simple and intuitive. The user is able to begin using the device very quickly. The menu of basic diagnostic operations is identical for all control units. These operations monitor the status of all control units on the motorcycle and do not make any adjustments to the settings. Basic diagnostic operations are operations that monitors the motorcycle status and do not interfere with the parameters settings. Control unit identification is a function that provides you the basic information about the control unit, such as part number, VIN of the motorcycle, or calibration ID. This function can therefore be used to verify that the motorcycle is fitted with the correct control unit. Reading and erasing the fault memory is the easiest and quickest diagnostic operation. However, this operation is often overestimated. Be aware that it may not always reveal the true cause of the fault. From the hardware perspective, the operation tests the input and output signals. It is important to know the error codes are differentiated into current, which are highlighted in red in the program, and temporary, which are highlighted in orange. The latter have occurred in the recent past. In some control units, temporary error codes may delete after traveling a defined number of kilometers. It is also important to realize that some faults may be indicated only after, for example, letting the engine warm up and traveling a certain distance. A typical example of this is a fault in the oxygen sensor. Erasing the fault memory is a simple operation but should be used judiciously. Information about a current fault cannot be erased if the fault persists. But erasing the information about temporary faults cuts off any access to the fault history. Actuator test is a very important diagnostic operation that tests the hardware connection between the control unit's outputs and the actuators it controls. This operation also checks the connection of the actuator and its functionality. The majority of tests must be performed with the engine turned off. Others have to be done both with the engine turned off and on, and some require that the engine be running. The vehicle should be inactive, in a stable position, secured against spontaneous motion. The device reacts to the responses from the control unit and informs the operator if there is any need to perform additional operations on the motorcycle. In general, test duration is limited. In some cases, the test is ended in reaction to a response from the control unit. In other cases, it may be possible to pause the test by pressing the return key, or the device ends the test automatically after some time. Parameter reading is another very important diagnostic operation, useful for analyzing found faults and/or discovering defects that were not uncovered by reading the fault memory. From the hardware perspective, this operation primarily tests the control unit's input and outputs. This function allows synchronous monitoring of information about the control unit's input and output signals that should also be detectable on the control unit's connector. In case of problems, it is best to verify the accessibility of these inputs and outputs with a measuring instrument, such as a voltmeter or oscilloscope. Parameter measurement helps reveal many faults that would not be discovered by reading the fault memory. The operator's first step should be checking the veracity of information. This analysis can help reveal partial faults on temperature and pressure sensors, for instance. Parameter reading with limits is an advanced operation that constantly updates. Here, the parameters are accompanied by information about standard or recommended limits. It allows the operator to quickly evaluate major deviations of parameters in particular. Parameter reading can often uncover hard-to-find faults, such as the causes of erratic engine idle by evaluating the state of the regulator of the idle system during controlled idle running. These causes can be easily revealed by reading the state of the IAC step motor. In the event of a mechanical fault, stuttering, of the idle regulator, the read values will be higher than nominal. This is caused by the engine not being able to make use of all the impulses from the control unit, which causes the control unit to repeat these impulses more frequently. On the opposite end, leakage in the intake tract under the throttle valve will be indicated by a lower IAC step value than nominal. You can also quickly and easily pinpoint issues with low fuel pressure at the injector in an injection system with a functioning closed-loop lambda control, without having to disassemble the fuel piping. This fault can be checked by measuring the injection time at idle speed and increased idle speed. For example, a 20% lower fuel pressure will increase injection time by 10%. Parameters can also be easily sorted and ordered as needed. You can also view up to 4 selected parameters synchronously in the form of a chart with an adjustable time axis. Proper choice of parameters allows performing a number of diagnostic operations. To illustrate, you can chart the parameters of the charging regulator while also displaying the speed characteristics of the engine with speed ramping up from idle, while also measuring the voltage in the accumulator. Parameter reading is a powerful diagnostic tool for operators knowledgeable in the functioning of the tested control unit. However, even partial knowledge will bring much valuable information.